there's a second synthetically useful reaction that makes use of the organocuprate. So here I have phenylcuprate, and my reagent is an alpha-beta unsaturated ketone. So the way we label this, we don't really give a label to the carbonyl carbon, but then from that, carbons attached to the carbonyl are considered alpha carbons. So we have an alpha carbon here, an alpha carbon here. And then if you have a longer chain, you can continue with Greek lettering. So the next carbon would be beta, gamma, and so forth. So this is a ketone. And because we have a double bond between the alpha and beta positions, this is considered an alpha-beta unsaturated ketone. What happens with the Gilman reagent is, again, we're kind of thinking of this as a phenyl minus nucleophile. The product is pretty easy to draw. All we do is draw our main framework, erase the double bond, and add the new group to the beta carbon. There's the product. So this is considered a conjugate addition because the double bond here and the ketone are conjugated. So let's take a look at how this reaction occurs. So when we do this mechanism, I'm kind of writing that CH3 minus in parentheses. The copper doesn't give that carbon nearly as much negative charge as the Grignard reagent and the lithium reagent, but mechanistically we can still kind of think of it as a carbon nucleophile. So what this does is it adds to the beta unsaturated carbon, and from there we're going to push these pi electrons over to here, and that pushes a pair of electrons up onto the oxygen. So we get O minus, a double bond here, and here's our new bond to, I did this one as a CH3 group. Up here we did a phenyl group, whatever we're using. Now that we're at this intermediate, the water can be added, and the water can protonate this oxygen. This second step, which is your workup step, could also be written as acid and water or dilute acid. So what we do is we protonate this oxygen. This gives us an enol. And you'll remember from Organic 1 that enols tautomerize to give ketones. So when that tautomerizes, you get the ketone. So if you need to review the tautomerization mechanism from Organic 1, you can do that.